table.
Will this be on the quiz tomorrow?
Today's will not be on tomorrow's quiz. No.
This has to do with triangles.
Sure. Okay, everybody got tangent ratio? Okay, what we're doing today and tomorrow is working with a few of the tangent ratios. Oh, Russell Brandon said you put it in. Tangent ratio is one of the trig ratios. So a trigonometric ratio is a ratio, which we've been doing last chapter. That's your comparison of two numbers. So the trig ratio is a comparison of the lengths of two sides of a right triangle. Since there's three sides, if you compare two, you can make different combinations. Those combinations have been given a certain name. And that's really what the basis of trigonometry is, using those ratios in triangles. When we do the trig ratios, we use the terminology opposite leg, adjacent leg, and hypotenuse. So we're going to practice identifying those correctly. Can you tell which are the legs and which is the hypotenuse? Done that before, because Pythagorean theorem, you had to know the hypotenuse. Which one's the hypotenuse? How can you tell? Okay, it is the longest. Sometimes it's visually hard to tell which one's the longest. It's across from the 90 degrees. Okay, so this one is definitely the hypotenuse. The other two are legs. But notice in my explanation, we don't just say legs. We have to identify, is it the leg opposite or the leg adjacent? And I probably will say it in the other order, opposite leg, adjacent leg. Oh, that depends which angle we're looking at. So I'm going to have you focus on this angle, angle A. Now, which leg is opposite of angle A? This one down here, this is the opposite leg. It is opposite of the angle. Colton, did you see that? I know you're sad that you're not gone, but you really need to pay attention here. Okay. Opposite of that angle is the leg, okay? And then this leg is right beside or hooked on to the angle that I'm focusing on. So that one is called adjacent. So we've got opposite leg, adjacent leg, and hypotenuse. Now if I switch which angle, it's going to switch some of those words. Okay, so you got that down in relation to angle A? Okay, now if you're doing notes, you probably would want to make a new triangle. I'm going to just do some erasing. Okay, I'm going to switch now and look at angle B instead of angle A. So is the hypotenuse still the hypotenuse, or did it change now? It's still the hypotenuse. It's still across from the 90 degrees. Is this adjacent leg still adjacent to angle B? No. Notice it's across the triangle. So across the triangle, now this one is opposite. So this is opposite leg, and this one changes. It is now adjacent leg. So it depends which angle you're focusing on. The opposite and adjacent are in relation to whatever angle you're doing. And notice that if I choose the 90-degree angle, there is no opposite leg.
That'd be the hypotenuse.
Yeah, that'd be the hypotenuse. So as we do the right triangle trigonometric ratios, we will never be looking at the tangent or the sine or the cosine of the 90. It's always going to be one of those little acute angles. Okay? Okay, so let me draw on the screen here a new triangle. And let's turn it a little bit so you have to think. Here's where my right angle is. Okay, and here's angle B. I want you to put the words on that triangle. Opposite leg, adjacent leg, hypotenuse. Hypotenuse was here, and then the opposite leg was that one, and the adjacent leg is this one. I think everybody that completed it had it right then. All right, so here's the terminology that we were just practicing. Hypotenuse is the side opposite of the right angle. The leg opposite is the leg across from the selected acute angle. The leg adjacent is the leg attached to the selected angle. So I'm going to put an A on this picture, and again have you put the words in there for your notes. If I label that one, what is this top edge? Is this one hypotenuse, leg opposite, or leg adjacent? Adjacent. Okay. So that's leg that is adjacent. This one? This is the opposite. This one? Hypotenuse. Okay. If we're good at those, then we should be good at picking out the opposite and the adjacent to make what's called the tangent ratio. And then tomorrow we'll do combinations with hypotenuse. That's the sine and the cosine. Are we done with the notes on this screen? Okay. All right, so the tangent ratio, the one we're focusing on today, is the ratio that compares the opposite leg to the adjacent leg. Write that on the board so that I've got it to look at all the time. Tangent compares the opposite leg to the adjacent leg. Today we don't need the hypotenuse really. We will tomorrow when we do sine and cosine. So let's put some actual numbers on this triangle this time. You think of a Pythagorean triple. 3, 4, 5. This picture might not look like a 3, 4, 5, but we know those numbers, so we'll put those on our triangle. All right, I'm going to pick angle A for right now, and I want to come up with what the tangent of angle A is. For angle A, which side is opposite? Which is adjacent. We're just going to make a fraction out of that. Okay, so looking at the angle A, which leg is opposite? 3. Okay. And which leg is adjacent? 4. Okay. the tangent of angle A is 3/4.
That's it.
That's it for right now. Angle B instead. Tangent of angle B. So now from angle B, which is opposite leg?
B, 4.
4. And which is adjacent leg? 3?
Yeah.
Why not 5?
Because that's
Correct, that's the hypotenuse, and we're not using hypotenuse here at all. Okay, question on that one? All right, I'm gonna change the numbers, ask you the same 2 questions though. Okay, let's see, another Pythagorean triple is 5, 12, 13. Okay, do those 2, tangent of A and tangent of B for me from that example.
so it's opposite
To angle A, yep.
to.
It's
So it goes opposite numbers first on
opposite leg goes on top,
okay.
adjacent leg goes on the bottom. So I would think on your homework, you would write this at the top to help you today. Tangent is opposite leg over adjacent leg.
Is this all we're doing on
Related to this, we haven't done everything we need to with it yet, but it's based on tangent today.
We're gonna need our calculator.
Yep, you're gonna need your calculators.
Is there like a lot of calculations we need to do?
I'd say you're gonna want a calculator, yeah. Is it really heavy? No, but,
Calculators are
I mean, is it real difficult is what I meant. Is it real difficult? No, but you do need to do some calculations. Okay, what was the tangent of A? 5 over 12. Tangent of B?
12 over 5.
You notice that they just flip over?
Yeah.
Mainly because the words opposite and adjacent change depending which angle you're looking at. Okay. Caught up? No? All right. Are you understanding how I'm picking up the numbers there? Okay.
So first we gotta find out if it's a Pythagorean triple, and then we have to do the
Oh, I just wanted to come up with some, well, I guess we don't have to have a Pythagorean triple. What if I had, let's mix up what we were doing yesterday or day before. What if this is the square root of 6
Oh, no.
and this is, I don't know, 10?
It's not what
I'm not even gonna put the hypotenuse because we don't need it for the tangent. That avoids it. Square root of 6 over 10,
10 over square root of
10 over the square root of 6. So it doesn't really have to be a Pythagorean triple. You can do it with other values. Okay, looks like we've got it. All right, so what your book's gonna have you do is come up with the fraction. We were just doing that, but I forgot to have you do decimal rounded to 4 places. So let's do that, square root of 6 and 10 that we just had. Okay, if we're doing the tangent of angle A, I'll call that A, and I have square root of 6 over 10, how do I get that into a decimal? Just normal, square root of 6 divided by 10. Let's see if we can agree on what that decimal number is. Square root of 6.
Zero point 2449.
Okay, and 4 decimal places. So 0.2449, there's a 4 after it. So do I need to round that up? No. Since that was only a 4, we'll just leave it up. And that's the tangent of angle A. Let's go to B. Tangent of B,
4.0824.
you're doing 10 divided by square root of 6?
Yeah.
10 divided by the square root of 6. Anyone having trouble operating their calculator to get these numbers?
Yeah, the calculator's pretty heavy. It's not gonna operate.
I shouldn't have used that word, huh? Was it 4.082?
5.
You would have to go up to 5 because it was 4 and then an 8 after that? You remembering how to round?
I think we get it.
I will guess that some will goof up. Let me just give you, for example, what if this were a 7 after this?
Well, then the
Round
9
up.
would go to
What would
0.
it become?
2.2445. It would be 2.245 and then 0 because it would go up.
Very good. Okay. I thought that maybe someone would go 0.3 or something, but yes. Believe it or not, students don't always round correctly. But if you've got that mastered, great.
I can believe it.
All right, now the tangent ratios, like for a 10-degree angle, a 20-degree angle, are programmed in your calculator, and they are on a table. I also want you to know how to read that table. I don't know if I made enough copies. Got your book handy? Open to page 50 or 705. There's a table that has the trig ratios. Got your book handy? Page 705. I know I ran some copies because my regular geometry needed copies of it, but you should have it in your book. This is in our regular geometry book for some reason. 705. Okay, we're going to try and figure out what the tangent of a 27-degree angle is. So that table has sine, cosine, and tangent in it, 705. So you would need to go down the angles till you get to 27 degrees, and then sine, cosine, go to the tangent column. And do you see the decimal 0.5095?
Yeah.
Okay, accurate to 4 decimal places, that would be the decimal you would get if you really had a triangle with a 27-degree angle and you could make the fraction with the 2 sides. All right, let's see if you read the table correctly. Tangent of, let's go 75 degrees.
3.732.
Yep. Couldn't agree.
3.7321. Okay, how about the tangent of 40 degrees?
0.8391.
Everyone getting that?
Yep.
All right, now let's try our calculator. Your calculator's programmed with these, okay? And so one thing we need to make sure is it's in degree mode. Do you see a little DEG in the screen?
That's what that means.
Yeah, degrees. There are different ways to measure angles, because if you hit mode or something and that changes, it'll be RAD, which is radians. Yep, up here the DRG. If you press that, you would see you can measure angles in radians and in gradients, but we want degrees. Okay, so everyone, leave it on degree. That's what we want, but that's how you would change it if it's wrong. I've had people take the test and it's not in degrees and you get all the answers wrong. It's not a good thing.
Sure.
So let's try the tangent of 27 on your calculator. So most of you have this type, it looks like. So you are doing tangent. So press the tangent button and put 27. Finish the parenthesis. When you press enter to 4 decimal places, 0.5095.
Yep.
You're
Wow.
not getting that. If you're not getting that number, it's in the wrong mode or you're doing it backwards or something.
Pressing the wrong button.
Okay, try tangent of 75, see if it agrees.
Yep.
I'm used to a calculator that goes in the other order. That's what I'm thinking up here.
3.3720.
And that would round up to a 1 after the 2 because of the 5. Okay, and tangent of 40?
Yep. Yep.
Okay, so you can use the table or your calculator. Actually, your calculator is going to be more exact because it's got a lot more decimals. But directions would probably tell you how far to round it. Okay, what we're going to do, these are the steps we're going to go through. I don't know if you need to write those steps right now.
Also be a pain to flip back and forth from your homework page.
To this, yeah, you'd have to put a bookmark there, do that. So we're going to try and find the length of a leg in a right triangle.
Kill, go.
You look more sophisticated if you put all the points.
Yeah, you look like you actually know
Like you know
what
what's
you're
going
doing.
on.
Yeah.
Like, oh, yeah, I know this.
All right, let's make up another problem. Let's say this is a 70-degree angle, And we're gonna try and find this side, and we know this side as, let's say, 24 inches. So let's try and find the missing side like this time. Colton, you'll be with us. Look what we did there, we wrote that equation thing down.
Over.
If I can't, 5 or 5.
You divided it, you said you did.
I don't think it's times on this one. And did you write this little fraction thing out?
Oh, you just.
8.2.
Okay, now tangent is opposite over adjacent. So this time it's 24 over x. Did everyone get that right?
Yes.
Opposite was 24, adjacent is x. So the x on the bottom this time. Okay. Now, I'm gonna put this over 1. If I cross multiply right now, I have to take x times the tangent of 70. And that will equal 24 times 1, which is just 24. Now notice where the equal sign is. It's between those things. It's not telling you to multiply tangent of 70 times 24. So if I want to solve for x, I'd have to get rid of the tangent of 70. Divide by it. Divide by the tangent of 70.
I was right, it's 40, here it's 8.735.
So x is 24 divided by the tangent of 70.
It's 1, 1, 4, 5.
Okay, is that just the tangent of 70?
This is divided by 24.
Okay, no. 24 divided by the tangent of 70.
That's
I'm getting 8.7.
8.7353.
I think it said tenths, so this is 8.7 approximately, so I'll change my symbol. All right, now I'm gonna write that one on the board here, just so we can compare those two. Okay, so what was the difference in why we did what we did? 70. Okay, we did the tangent of 70 is 24 over x. Okay, I want you to compare those last two and tell me what the difference is. Why we divided in one and we multiplied in the other.
Because when we were finding the opposite leg and the other we were finding adjacent.
Okay, on one of them, you were finding the opposite, and the other you're finding the adjacent. So here, the variable was in the top because we were finding opposite. Here it was in the bottom because we're finding adjacent. Now, do you need to memorize when you multiply and when you divide? No. You just need to write this first step down and then cross multiply correctly. Let's do another one. Find the height of a tree. Okay, here's a pretty tree. We're gonna try and find how tall that tree is.
I like your tree.
The height of the tree, okay? What I could measure is, if I'm trying to figure out the height, I could measure how far I am away from the tree. This would be interpreted as like a right triangle. Let's say I'm 40 feet from the tree. And there are devices to measure angles. I can measure this angle, and it comes up to be a 39-degree angle. What is the height of the tree? To the nearest 10. We can use tangent. Okay, write that first equation down because it helps me know whether to multiply or divide.
Got it.
Okay.
Tangent of what angle?
So
And is it h over 40 or 40 over h? H over 40? Opposite? Yes. Over adjacent.
32.4.
And you're coming up with how much? 32.4?
Yep.
39? Okay, so you were rounding for me earlier. Yes, sorry, we were talking about tenths in this part. Earlier, we were doing 4 places. I would agree with you. Okay, but yeah, I think the directions here on the heights, they're actually having you go tenths. So that's the approximate height. How many got it right? Show me hands.
Can't see my hand, but it's up.
Okay. Colton, did you get it set up? Okay. Kylie, did you set it up right? Yeah. Jamie, did you set it up right? Okay, so is it just the solving? Oh, she did? Okay. Okay. So setting it up is a key to doing these correctly. Right, let's keep practicing. Let's turn the triangle. And I'm gonna give you the big angle, 80 degrees. Shall we find the adjacent this time? And let's go with 30, I'm on the 30s today, I can tell. 38 inches. Okay, find the other side. Write down this equation to start with. Write that down. I want to see that on everybody's papers, including Colton.
Okay, so when you give them their quiz, and this is on their test, you want to see
I
that?
want to see that,
Okay.
because if they don't do that, they're probably not going to solve
I'm
it.
just saying, a lot of them are doing them on their calculators without writing
Yeah.
that out.
I want to see that written out so that I can tell that they're doing the right thing on their calculator, multiplying or dividing. It changes depending on what we're doing. Yes, I want to see that. Tenth. Yep, let's go nearest tenth because we're finding a side length.
Okay. Got it.
The angle's not 38 degrees.
6.
You'd write,
Honestly,
you'd write this type of thing for me.
What's that?
Tangent of 80 degrees.
It's, yeah, 6.7.
You don't have to do second. Is this a dividing problem?
Yeah.
Is it?
Yep, it is.
All right, so you have tangent of 80 degrees
You put in 34.
equals
Yeah.
38 over x.
So that's what equals 6.
Now, which way do you divide?
38 over.
So it's 38 divided by the tangent of 80?
Yeah.
Okay, so Colton, it sounds like you were writing it down right. I was not following where you were coming up
Oh.
with knowing that. So
Yeah,
38
smart
divided by
again.
the tangent of 80. So our answer was how much?
6.7.
6.7?
Yes.
Everybody got that right?
6.7004.
Okay, one more and then it seems like you're doing well. We had to find the adjacent that time. Okay, let's do one more where we find the opposite. Okay, so here you're gonna find opposite and you know the adjacent and this angle a little bit bigger, 86 degrees this time. too big. Oh, gets to be quite large.
Yeah, it looks like,
No, I don't think that's right. Did you set up the fraction thing? Okay, tangent of 86 equals what over what?
No, because it's opposite.
Opposite. Opposite over adjacent. So this one, you actually multiply. And 86 is probably a little bit big for that angle,
just a lot.
because the answer comes out to be 228.8. And that is quite large in relation to, if that's 16, there's no way
That
that's,
is like,
so I think I misjudged my angle up there.
Wow.
Question on figuring those?
Yeah, you can understand.
Now realize when you go back to the beginning of the chapter to start some of the, or section to start some of the problems, the beginning thing we did was with like a 3, 4, 5 triangle, and I just asked you, what is the tangent of A? You didn't really have to use this.
3/4.
Okay, the tangent of A was 3/4. Oops, not over 7, over 4. And I think that the book is probably asking, put that in decimal. You still don't need the tangent button, you just need 3/4 is 0.75. If it says 4 places, put the zeros there to show the 4 places. So remember, the beginning was just real simple things. So here's what you're working on and a little bit of review for your quiz tomorrow. Page 560.